We need to identify some additional terms when we start talking about calculating payments and loan balances. First, the accrual rate is the frequency at which a loan requires interest to be accrued, and we calculate it as the interest rate divided by the number of compounding periods. The pay rate is the ratio of the loan payments to the loan amount, and that's not necessarily going to be equal to the accrual rate. There are a number of amortization patterns for these loans. First, a loan could be fully amortizing, and so that means that the pay rate is going to exceed the accrual rate, and therefore the loan will be fully paid at the end of the term. With a partially amortizing loan, the pay rate will result in a payment that will exceed the accrued interest, but not by as much as the payment for the fully amortizing loan. So we will be reducing the principal over time, but not enough for the loan to be fully repaid. With an interest-only or a zero amortizing loan, the pay rate will equal the accrual rate. And with a negative amortizing loan, the pay rate will be less than the accrual rate. So let's assume a fixed-rate mortgage loan is made in an amount of $60,000 at a 6% nominal rate of interest for 30 years. So if we want to calculate the payment on that loan, we would calculate N as 360 or 30 times 12. The I is going to be 0.5 or 6 divided by 12. The present value is going to be $60,000, and the future value, because it's fully amortizing, will be 0. We'll solve for the payment, and we'll get negative $359.73. Now let's change this a little bit and make it a partially amortizing loan. So let's assume that our fixed rate mortgage loan is made in an amount of $60,000 still at 6% for 30 years, but with a $40,000 balloon payment at maturity. So then in this case, now N is still going to be 360, 30 times 12. I is still going to be 6 divided by 12, or 0.5. The present value is still going to be $60,000, but because it's partially amortizing, the future value will be negative $40,000. It's negative because at the end of 30 years, we're going to have a cash outflow in the form of a balloon payment of $40,000. So now if we solve for payments, we're going to get a payment of negative $319.91. So you should notice that this is less than the payment on the fully amortizing loan, which makes sense because the payment is not enough to fully repay the loan over the 30-year term. Now, what about a zero amortizing or interest-only loan? So if we still have our $60,000 6% 30-year loan, but it's zero amortizing, N is still going to be 30 times 12 or 360. I is still going to be 6 divided by 12 or 0.5. The present value is still going to be $60,000. But now the future value is going to be negative $60,000 because we haven't paid any principal over the life of the loan. We've only made interest payments. So now if we solve for the payment, it's negative $300,000. So now what about a negative amortizing loan? So in this case, let's say that our $60,000 6% loan for 30 years is going to have a balloon payment of $80,000, which is more than the initial loan amount. So in this case, N will still be 30 times 12 or 360. I will still be 6 divided by 12 or 0.5. the present value will still be $60,000. But now the future value is negative $80,000 because we're going to have an $80,000 balloon payment due at the end of 30 years. If we solve for payment, we get a payment of negative $280.09. Let's change gears a little bit and calculate the loan balance at some point in the future. So now let's assume our fixed rate mortgage of $60,000 at 6% for 30 years is going to be repaid after 10 years. So let's find the balance after 10 years. So the way we'll do this now is we're going to solve for the present value of the remaining payments. So our remaining payments after 10 years would be n equal to 20 times 12 equals 240, because 10 years and 10 times 12, or 120 payments, have already been made. There's 240 payments left, and we're solving for the present value of those payments. So our n is going to be 240. Interest rate is still going to be 6 divided by 12, or 0.5%. But our payment is going to be the payment that we calculated before on that fully amortizing loan. So that was negative $359.73. Future value is 0 because this is a fully amortizing loan, but we just want to know what the loan balance would be after 10 years of those payments. So if we plug all that in and solve for the present value, we will get $50,211.39. And then we can also do that meaning calculate the future loan balance for a partially amortizing, 0 amortizing, and a negative amortizing loan. So in all three cases, the n will be 240 because we want to know what's the loan balance after 10 years. So we're calculating the present value of the remaining 20 years of payments. So n in all three cases will be 240. The interest rate, I, in all three cases will be 6 divided by 12, or 0.5%. And we will use the payments that we calculated before. So for the partially amortizing loan, it's negative $319.91. For the 0 amortizing interest-only loan, it's negative $300. And for the negative amortizing loan, it's negative $280.09. We'll use 0 as our future value in all the cases, and we'll just solve for the present value. Again, we're solving for the present value of the remaining 20 years of payments. So for the partially amortizing loan, the balance after 10 years is $56,737. For the 0 amortizing loan, it's $60,000. And for the negative amortizing loan, it's $63,263.